Imagine floating in space, gazing at the massive, swirling storm clouds of Jupiter, the largest planet in our solar system. Suddenly, an absurd thought crosses your mind. What if you lit a match here? Would the entire planet explode in a fiery inferno, burning up like a celestial bonfire? Or would nothing happen at all? Let's dive into this fascinating thought experiment and explore the science behind it. Jupiter is an enormous gas giant, about 300 times more massive than Earth. However, despite its size, it is much less dense than our planet. Unlike Earth, which has a solid surface, Jupiter is composed almost entirely of gas. The planet's atmosphere is a complex mixture dominated by hydrogen 90% and helium 10%, with small traces of methane, ammonia, and other gases. Given this composition, one might assume that Jupiter is highly flammable, especially considering that hydrogen is a key component of many combustion reactions. However, fire needs three essential elements to exist: fuel, heat, and an oxidizer, typically oxygen. This brings us to our first major problem. Jupiter lacks oxygen. Fire is a chemical reaction known as combustion, where a fuel source reacts with an oxidizer to release energy in the form of heat and light. On Earth, this oxidizer is oxygen. When you strike a match, the friction generates heat, converting red phosphorus into white phosphorus. This then reacts with oxygen in the air to ignite the matchstick's chemicals, producing a flame. Without oxygen, this process cannot happen. Jupiter's atmosphere, despite its abundance of hydrogen, has almost no free oxygen. This means that even if you could strike a match in Jupiter's atmosphere, it wouldn't ignite. But let's get creative. Suppose we develop a special match that doesn't require external oxygen to ignite. We could design a match coated with a chemical that, when ignited, releases its own supply of oxygen. Potassium chlorate, for example, is a substance that can decompose under heat to produce oxygen. In theory, this would allow the match to burn for a short time. However, a single match isn't enough. If we want to set Jupiter itself on fire, we need an astronomical amount of oxygen. To burn all the hydrogen present in Jupiter's atmosphere, we need an amount of oxygen roughly 6 times the mass of Jupiter itself, far more than what exists in the entire solar system. If lighting a match won't work, what about something much more powerful? In 1994, the comet Shoemaker-Levy 9 collided with Jupiter, producing explosive impacts larger than Earth itself. These impacts released energy equivalent to multiple nuclear bombs. If anything could ignite Jupiter, surely this would be it. Yet, despite the massive explosions and the intense heat generated, no fire or flames appeared. Why? Again, the answer lies in the absence of oxygen. No matter how much energy is released, combustion simply cannot happen without the right chemical ingredients. Let's indulge in a purely hypothetical scenario. What if we somehow transported enough oxygen to Jupiter to make combustion possible? If we could mix the right proportions of hydrogen and oxygen, we could theoretically create a massive planetary fireball. However, the logistics of transporting this amount of oxygen are impossible. Even if we could, the result would be catastrophic. The sudden combustion of so much hydrogen could trigger massive explosions, fundamentally altering Jupiter's structure, perhaps even breaking it apart. But this is all theoretical. Such an event is unlikely to ever occur naturally. This thought experiment teaches us several important lessons about fire, chemistry, and planetary science. Fire requires more than just a fuel source. Oxygen is a crucial component, without which combustion is impossible. Hydrogen alone isn't enough. While hydrogen is flammable, it cannot burn in the absence of an oxidizer. Space is full of extreme conditions. What seems intuitive on Earth, like lighting a fire, may not work elsewhere in the universe. So, if you were to light a match on Jupiter, the only thing that would burn is your curiosity. Despite its abundance of hydrogen, the planet lacks the necessary oxygen for combustion, making the idea of a fiery Jupiter nothing more than a sci-fi fantasy. But this raises other fascinating questions. What if we could artificially introduce oxygen into a gas giant? What if two massive planets collided? The universe is full of endless possibilities, and each question leads to new scientific explorations. So, while we may never see Jupiter engulfed in flames, the mysteries of space continue to ignite our imagination.